This summer, a number of earth science teachers are together revamping the earth science curriculum, and we're incorporating more research-based techniques within the earth science curriculum. Each one of us is taking on a research project of our own, and each of the different earth science teachers will explain their project. The idea out there, or the myths out there, is that research is a step-by-step process, and it's really not. I think what you'll learn from a lot of these different teachers is that there's just not one single way to do it.
Hi, I'm Jesse Shea, and I am an earth science teacher at Loudoun Valley.
I'm Tom Pasco, an earth science teacher at Dominion High School. Our project is about craters on the moon, and we thought it would be interesting to see if the rock type affects the size of a crater. And I've been doing an activity for 25 years where you use a slingshot, which is one of the more exciting activities that kids can do, and creating craters in the classroom. And what we thought was, because the moon has basically two types of surfaces. One is the dark area called the Marias, and the light area called the Highlands. And we thought if we changed the rock type, it would affect the crater size.
Ultimately, we want to see if maybe scientists could find out what the soil would be like on another planet or moon based on the characteristics of the crater. So what we're about to do is launch some meteorites, marbles, into different types of soil and see if we see any patterns. That might lead us to a lot of different or new questions. What's funny is it's not really following the scientific method. We don't really have a hypothesis yet, and that's okay. We might come up with one after doing some experiments looking at some of the craters that we make. Science doesn't have to follow specific steps every time. Sometimes it's easier to maybe test a little bit first and then make some observations, maybe some research first. Each step can lead you to another step that's systematic for you. I'm not a planetary scientist. I don't have the resources to that, so I emailed a college professor who studies that, and he said it was a really good idea and he's interested in finding out. He gave me some ideas on how to make the experiment work better. So it's always good to ask people that are experts in it.
Hi, I'm Chris Elliott. I'm a teacher at Parkview High School. For my summer project, I did an environmental site assessment, which was taking a look at a particular piece of property and looking at all the things around it and potential environmental threats. And one of the things I learned during this process was that science is not something that's always just done in laboratories. It's something that's really done out in the field. It's a real process that you go through. It's not necessarily guys in lab coats. It's real data, taking data from a variety of sources and putting it all together to draw conclusions.
Hi, I'm Lori Gould. I'm the Science Department Chair and Earth Science teacher at Dominion High School.
And I'm Sue Wright. I also teach Earth Science at Heritage High School.
We're here to just explain about a project that we're working on this summer, a research project. We started this research because we were interested in global climate change and issues associated with increased carbon dioxide in the atmosphere. And we also wanted to see if we could relate our study to a hands-on research project related to geology and rock material. And in our background research, we found that carbon sequestration, which is the taking of carbon dioxide from the atmosphere by either ocean water or rock material, can occur at various places around the Earth. And one place that it occurs is in Oman, which has large deposits of a rock called peridotite. And peridotite is a rock made up of a beautiful mineral called olivine. So what we wanted to do with our study is answer the question that says which rock types could be used for geologic carbon sequestration. We want to see if other minerals like olivine can be used to store carbon dioxide from the atmosphere in rock material below the surface. So we developed a procedure to simulate the atmosphere and expose the olivine material to carbon dioxide in the atmosphere, see if a chemical reaction took place, and if the mass of the olivine would increase, that would indicate that a reaction was occurring and we were therefore removing oxygen from the atmosphere. Carbon dioxide from the atmosphere, sorry, not oxygen. So we've been working on our study here for a while, and it's going very well. There's one thing that I would suggest to you if you're doing your research, and that is that you have to be flexible. A lot of our procedures did not work out as we had planned, and we had to make adaptations in what we were doing. So as a scientist, sometimes you might have the best of intentions, you work on your procedures, you design your experiment, but then you have to adapt to your situation and to what equipment that you have available. And we found that we had to do that, which wasn't a problem. It was kind of fun. We kind of felt like mad scientists making things up, but it worked really well. So that's one piece of advice that I would give you if you were doing your own research.
And another piece of advice is when you're doing your background research, you're supposed to look up journal articles, and that's how we found this experiment. And the further we read, we realized, we might not be able to do it in the classroom. So what you can do, and what we did, was we emailed the professor who wrote the journal article that we were using for reference, and he wrote us right back and even gave us some olivine, some crushed olivine, gave us some advice on how to run the experiment in a classroom setting versus a university setting. So that would be my piece of advice, is if you come upon some problems, go ahead and contact a professor at a university. So,
Good luck with your own
yes, good
project.
luck.
My name is Todd Monepower. I teach earth science at Loudoun Valley High School. And this summer I've worked on a project on Virginia geology, looking at all the counties in Virginia, looking at all the provinces of Virginia, figuring out what types of rock are found in each county, how old the rock is, and correlate that to how Virginia was formed. This summer has been a good experience with me because I took a trip to the highest point in Virginia, which is Mount Rogers, which is in Grayson County. So I got to learn about things about Mount Rogers I never knew. I've also made contacts at some college universities where they provided me some information to help with this project. So the project's been a good experience. Still trying to draw lines of exactly what I want to do. There's a lot out there, so trying to get the big picture, bringing it down to the small picture. That's probably been my greatest challenge.
Hi, I'm Mike Wagner. I'm an earth science teacher, geospatial science teacher, science department chair at Heritage High School. My project, I'm a meteorologist. That was my original degree before I became an earth science teacher. I worked as a industrial forecaster for 3 years. So my project is related to tornado outbreaks. What I'm interested in is, we know that in the middle part of the country, Tornado Alley, we have numerous tornadoes, and it was because of the influence of the Gulf of Mexico, along with dry air coming out of the northwest. That's what creates Tornado Alley and some of the biggest tornadoes in the world. I want to know, does the Chesapeake Bay influence tornadoes? I've seen in the past where there's a lot, seems like tornadoes are greater in intensity, greater in number east of the Chesapeake Bay, or as you get closer to the Chesapeake Bay. And just like the Gulf of Mexico influences Tornado Alley, I feel that on a micro scale, Chesapeake Bay has an influence on Mid-Atlantic tornadoes. So that's the project that I am doing. Some of the things that I'd like to share with you about some of the, I guess, problems that I've run into. One is data. I've been looking at a lot of tornado data. There's not a whole lot of data in the Middle Atlantic. Definitely not to the extent of what's in the Tornado Alley. So I've got a smaller data set to work with. In addition to that, because I'm looking at thunderstorms created by a front or a front system, I want to take away the influence of hurricanes, because on the East Coast we do occasionally get influenced by hurricanes, and hurricanes are already known to produce tornadoes. So because of the movement of the hurricanes up the coast, it would be a big influence on the Mid-Atlantic tornadoes to incorporate tornadoes due to hurricanes. So I have to look at all the data, look at all the different dates of hurricanes in the past, and remove tornadoes that occurred during hurricane outbreaks or hurricanes moving up the coast. Once I get that cleaned up, then I can look at the Mid-Atlantic and look at data that actually goes with what I'm trying to look at. And it'll be a smaller data set, and it is a smaller data set to look at, but the data is there. That was one of the biggest problems that I've faced in this research project. That the data, even though I have a smaller data set, I've had to scrub out some more data because I don't want influences that don't relate to my project. And hurricane-produced tornadoes don't relate to what I'm trying to find out in how the Chesapeake Bay has an influence.
I'm Larry Wharton. I teach at Parkview, and when I look at the Science Summer Institute we've just participated in, one of the things I really came to appreciate is just how every day we take the scientific investigation and endeavors into our daily lives. We can use it driving a car, getting to work, getting to school, sports. Every activity is based on asking questions and then coming up with how we're going to get, what information do we need to know, how are we going to get the information, what do we change, what do we observe, and then how do we make the best informed decisions. So I think it has really opened my eyes just to see how useful this scientific investigation is on a day-to-day basis. And that's really one of my big takeaways. Another thing that comes to mind is just you don't always get the right answer the first time out. You have to go back and relook at things. We changed that in our project this summer several times, and each time we came back, we found that we came up with a better product and closer to really what I thought makes more sense down the road for us to look at in terms of, say, we investigate hurricane activity, for example. So to really summarize, we look at how do we come up with essential questions and how we end up using the information to really make common sense out of the day-to-day activities of life.
Hello, my name is Andrew Youngs. I teach earth science at Dominion High School, and I've undertaken a research project this summer that came to me in a flash of inspiration when I was on the skipjack, an oystering vessel on the Chesapeake Bay. One of the demonstrations that they did was to take some oysters and put them into some very turbid water, and in a matter of about an hour the water was completely cleaned up. So I started wondering, wow, I wonder if that affects water chemistry at all. So what I've done is set up some aquariums, get the water set up for the oysters, and I'm going to get some live oysters, and believe it or not, I managed to get those through a local grocery store. They're going to arrange for me to get some live ones, and I'm going to set the oysters up in the tank, and we're going to be checking nutrient levels, phosphate and nitrate levels, to see if the oysters not only clean up the turbidity, but clean up the nutrient levels in the water. Now, I know nothing about this. This is something completely new to me. One of the things I found I had to do was call on experts in the field. So I've contacted scientists at the Chesapeake Bay Foundation. I've contacted people at Carolina Supply to talk about what types of supplies I would need. So when I can't fill in the gaps with a good search on the internet or find a book, I get on the phone and start calling people, and I found that people respond. One of the things that I feel a little shaky about is I don't know if this is going to work. But you know what? I think with science research, it's really important to take risks. I've learned a lot along the way. I think it's really not about the destination, but it's about the journey. And so I don't know what the destination is going to be right now, but I'm sure enjoying the journey.